Okay, this is the first test review. Alright, first thing we're going over is we're plotting the points and finding a line of regression and drawing the trend line. Alright, I'm going to do one of these. No reason to do it twice on here. First point is -8, -7. First one is always my left and right. Second one is always my up and down. Okay, so we have -8 here, -7. There's that point. 8 to the left, 7 down. Next one is -3, -3. That's that point. -2, -5. There's that point. And 2, 5. 1, 2, 3, 4, 5. 3, 0. 3 to the right, 0 up or down, and then 9, 9 is up here. Those are my points here. To draw a trend line, I'm going to pull a pencil out here. What I like to do is just kind of start sketching a line and get straighter and straighter and make it more and more solid. So that looks like my trend line. My trend line is going to go somewhere through that point, through that line. There is my trend line. We are going to go ahead and do everything with the regression now. Turn your calculator on. Always second plus 712 to make sure there's nothing in there that shouldn't be. We are going to put in these points. To put in these points, we're going to go to Stat. And then Stat, we're going to go to Edit. That's the first one. And we're going to plug these in. X is first. My X's are my L1. We do -8. By the way, negatives are done with the white negative sign. If it's a subtraction in between two numbers, we use the gray one. Alright, so we have -8. Enter. -3. Enter. -2. Enter. 2. Enter. 3. Enter. 9. Enter. Then I can go over to the other side. -7, enter. -3, enter. -5, enter. 5, enter. 0, enter. 9, enter. There are all my points. I can go ahead and quit that, get out of that. One thing we're going to need to do is we're going to need to turn diagnostics on here. The diagnostics allow us to give us the R value, which tells us how strong or good the correlation is. To turn that on, we have to go to this catalog button. To get to the catalog, since it's in blue, we press the blue key right here. So second 0 will get us to the catalog. There's my catalog. We need to go to diagnostics on, so go all the way down to the D's and turn the diagnostics on. If I hit enter one time, it is not on. You have to hit enter a second time, and that gets us the done word. We are done when it says done there. You could do this before you started, but now, or between doing the stat stuff, but now that it's on, it stays on until you turn it off or reset the calculator. So now to go back to stat and find our linear regression, we press the stat button again. We're going to go, instead of to edit, we're going to go over to the calculate. So calculate, and we're going to go linear regression. It's the fourth one down. As you can tell, our line here is linear, so that's why we know we're going to do linear. So fourth one, and I like to go to my store regression equation. Why do I want to go to store regression equation? Because that's going to put us able to put our equation directly into our y equals button, so we don't have to retype it later. So if you, from here, right by the store regression equation, press the vars button. When I press the vars button, I get a window that says vars and y vars. We want to put it in the y1 place, so we're going to go to these y vars, and it's a function. You haven't been taught any of this, so we're going to go to function, and there's y1. Go to y1, and now it says we're going to store the regression equation into y1. Tap enter a couple more times. There's our equation, and we'll look at y1 in a second. So my possible line, I start off with y y equals, my a is my slope. Depending on how exact you can be, this is basically 1, but for simplicity, or from just right now, let's round that 2 places. 0.97x, that's my slope, 0.97, plus my y-intercept, which is b. I don't actually need a plus, it's actually minus 0.32. What it looks like is basically these are kind of falling along the parent function. Now, correlation. Oh man, sorry, I hit a wrong button, or hit a button accidentally. My correlation was, I don't know. Let's go back. Calculate. My correlation coefficient was 0.92, which means I had pretty good correlation. It was positive correlation, and it was strong correlation because of the 0.92. And that number was 0.92. Closer you are to 1, the better. Anything above 0.85, 0.9, that's really strong. Anything in the 70s or 80s is okay. Anything below 70s, not really worth it. Next one you can put in yourself, same thing. Put all that in there. Steps for finding linear regression in your calculator. I just went over everything I put in there. When you find linear regression on a calculator, what do A, B, and R represent in your equation? Like I said up here, this is my slope. B is my y-intercept, and R is my correlation coefficient. Correlation coefficient. Alright, let's look at an example. Let's go through this whole example for us together. Okay, it says an automobile consumes gasoline at a constant rate when the speed is constant. Gasoline is consumed at a constant rate shown at the right. The longer the automobile runs, the less fuel available in the tank. With this in mind, answer the following questions. Just a real quick review of correlation. If correlations are going the same direction, that means one is going up, one is going right. They're both increasing. That's positive. If one is decreasing and one is increasing, that's negative correlation. In this case, my time running is increasing and my gas mileage is decreasing. So this is going to be negative correlation. Minutes of gasoline consumed, that is going to be my X. Top one or left one is going to be my X. This is my Y. Also L1, L2, just like that. Independent variable in this, it represents my minutes, and the dependent represents my gallons of gas. Write the function g. Alright, so let's go ahead and let's just use the calculator for this. Let's go back to stat. Going to edit the values. To clear these values, go up to L2. Tap the clear button. It's right here below the keypad. Press clear, enter. Go over to L1, clear, enter. Now it's cleared. List all these values. 0, enter. 2, 0, enter. 4, 0, enter. 5, 0, enter. 6, 0, enter. 8, 0, enter. Go to the other side. 20, enter. 18, enter. 16, enter. 15, enter. 14, enter. 12, enter. We already have our diagnostic on, even though we don't need it for this one. Just get in the habit of turning it on for that test. Better to do it after or before than after you've already done it one time. Okay, now we are going to go back to stat, and we're going to go to calculate linear regression. Even tells us it's linear, and I want to go down back here, review the steps with you again. Store regression equation, we press the bars button, go to the right, function y1. Alright, so here is my equation. There's my equation in there. Nice and simple equation. Let me go switch sides here. My gas, which is my y, is equal to my slope in this case at A, is negative 0.1 x, and my B is 20 plus 20. There's my equation. I guess in this case your x is also your minutes, so I should have put M there for minutes. Now it says to predict the gasoline remaining if you have used 111 minutes of gasoline. So we have to go to 111 in the table. First we got to make sure it's in y1. Because we did the whole y bars thing, it's already in y1 for us. Press y equals, there's that equation I just put over there. There's that equation right there. Now I go to the table. Second, graph. There's your table. I need to go down to 110. I don't want to scroll down like this 100 times. So for the table, blue table set, blue, window, and I want to start. I'm looking for 110 minutes. 110, enter, and then I can table. I am back at 110. So 9 gallons left. In regression, we predict the future. Relationship. Number 5 is the exact same thing you're going to do. Just a quick refresher. X, Y, L1, L2. Line of best fit. Correlation coefficient. Correlation coefficient is R. Remember, if it is close to 1, it is strong and fits very well. It will be a very, very good predictor of the future. If the annual rainfall is this, that's my rainfall. That's my X. That's what I'm going to put into the table, and I'm going to get out how many millions of frogs there'll be. Okay, given the scatter plots. Number 6, we're doing transformations. Given the scatter plots and trend lines shown, draw a better line of best fit. Describe the transformation. I'm going to go ahead and draw these in pencil. Just going to. There we go. There's my line of best fit. Doesn't have to be perfect. I look across that. First thing I notice, my y-intercept. So what needs to happen to my y-intercept? Y-intercept has to shift down or decrease by 1, 2, 3, 4, 5. And then my slope. What has to happen to my slope? My slope needs to get a little bit flatter, but it also needs to go from negative. So it needs to reflect across x-axis and get flatter. Now what's going to happen with that is, here's the shift down. The y-intercept is decreasing, which is going to bring it here. When we reflect it, it's going to do that, and the flatter is going to make it less steep, and that'll line up over it. Next one, let's go ahead and draw that trend line. There it is. That one's pretty easy. Pretty strong correlation, all close together. Y-intercept shifts up 1, 2, 3, 4, 5, 6. That's my B, my y-intercept. My B is going up 6, or adding 6 to my B. Once it gets up there, that line's going to look something like that. it's going to need to get steeper. So my slope is going to get steeper. That means my m is going to increase in value. Okay. 7, same general idea. Trend line, give me an estimate of what that line is going to be. Just the y-intercept is going to go down, slope's going to get a little bit steeper. There's your hint for that. Okay, solve the systems of equations by graphing. Okay, so we have my first equation here. I'm really happy about this equation right here because it is already solved for us. My y equals is already there. I can plug this in the calculator or graph this very easily. So let's graph it. When I graph this, I start with my y-intercept. I start with my y-intercept. I start at 5. 1, 2, 3, 4, 5. From there I use my slope. Top number says I go up. Bottom number says left or right. The 1 says go up 1. The bottom 2 says go to the right 2. Up 1 over 2. Up 1 over 2. This is my line skeleton. Go the other direction. Make sure it stays in the right line. Make sure it stays in the line. Doing the opposite. There's my line. If you want to connect the dots, I'm not too worried about you connecting dots. Just put a light line in there. Luckily as well, my next one already has y equals 2. Start at 10. My slope here, it's not a fraction. I'm going to go ahead and make it a fraction. Top number says to go down 2. 1, 2. Bottom number says to go right 1. Down 2, right 1. If you'll notice in this class, when I tell you to graph something with the system, they always intersect at one of these points I have you graph. So that's your solution right there. Let me finish my line, and we'll look at that in a second. So my solution is this point right here. That is 2. That's your x value, 2. And then here is your y value, which is 6. There's my solution. In the calculator, we can put these two equations in. Go to, just turn it on. Go to y1, clear it out. Alpha y equals 1 over 2 x plus 5. This one is negative 2x plus 10. And what we're going to do is we're going to look at the table. Very rarely do you want to look at the graph on the calculator to get an exact answer. What we're going to do is look for these to be equal. We're back here way at 110. I know the answer is lower, so I'm going to go back to my table set and just start at 0 again. Were they equal? They are equal. Where did it say the solution was? 2. There's 2 right there. So there's my solution, 2, 6. Yes, the 6 repeats. Where it repeats, I just want these first two numbers, 2, 6. Because this one's always going to repeat. That's how we find it. Number 9. On number 9, you have to do a little bit of work to get in y equals. My first two are already set up for y equals. So let's go ahead and solve this one for y equals. Here is my y. This is what I am solving for. This y right there. This 2x over here is not supposed to be there. It needs to be on the other side. Advanced trick, you can just move this over across the equal sign and change the sign. It works. Mathematically, we subtract 2x from both sides. This goes to 0. Bye-bye. Gone. 0 pair. Y comes down. Equal sign comes down. These are not like pairs. Sorry, like terms. So that there, plus 3. Again, like I said, you can just move that over, change the sign. That's what it'll be right there. Now we actually have my y equals. Let's do it one more time. This one has 3 steps. That took us 2 steps. Let's try one of the 3 steps. here is my y. That's what I'm solving for. I want to take this 2x. I need to get it over there, just like I did up here. I want to move it over. Again, you can move it over, change it to negative 2x, and it'll work. But here's the math behind it. Minus 2x, minus 2x. Keep that equation balanced. That goes to 0. I have 2y is equal to negative 2x plus 4. If you notice, now that I'm at this point, I did the same thing I did up here, but my y is not by itself. I still need to get that by itself. What I do is divide by 2. That goes to 1. Y equals negative 2 divided by 2. Well, you can use a calculator if you want. That is negative 1x, or just negative x, and that is 2 right there. If it's negative, you have to divide by a negative, and that changes all of our signs. If you divide by a negative and we have an inequality, well, then you have to flip the sign as well. But that's later on. Now we have our y equals, and we can graph those. I'm not going to graph those for y'all. That's most of the work done for you right there. So let's look at a couple of word problems. Let's do my example here, angle B and angle A. So what I have is an angle. Most of y'all are coming from geometry, so it should look familiar. I have angle A. Sorry, total thing here is 90 degrees. Angle A when you measure this is the sum, sorry, yeah, there's some. When I add angle A and angle B, I get 90. Then it tells us angle A is always equal to, angle A is equal to 30 less than, minus 30, twice angle B. So from that we have to make two equations. My first equation is this, the sum of the measures of the angles. Angle A plus angle B is equal to 90. Then we need this one. It says angle A is, and I wrote that down here for us already. Angle A is 2B minus 30. Let me check something. Let's go ahead and solve this because I don't see any other system solving on here. Okay. So what we're going to do is we're going to take these systems, these two equations, and solve them. If you notice, I have A equals. So I can take these two things, sorry, those three things are all the same thing. So instead of this A, I'm going to put all this into that A. 2B minus 30, that's my A, plus B equals 90. Okay? Then I can simplify that. These right here are like terms. 2B and B are like terms. My parentheses don't matter. There's no coefficient in front of them to multiply or distribute. So 2B and B, 3B minus 30 is equal to 90. 3B, add 30 to both sides, and I get 120. Divide both sides by 3. B is equal to 40. So now I have an answer for B. When I have B, I can go ahead and put that in right there. So A is equal to 2 times B. B is 40 minus 30. If it makes it easier for you, calculator can do most of your work for you. 2 times 40, 2 parentheses 40 minus 30, enter, there's your 50. So angle A equals 50, angle B equals 40. So this is 40 and this one is 50. And if you look, adds up to 9. 40 plus 50 is 90. Alright, 19. We're going to set the equations up and we're going to solve by elimination. We use substitution for this one because we have a variable already equal to something. It's easy to substitute back in. This one we're going to get two equations in standard form. Shopping at Savers Mart, Lisa buys her children 4 shirts and 3 pairs of pants and spends this much. She returns the next days and buys 3 shirts and 5 pairs of pants for $115. What's the price of each shirt and pants? So my price of my shirt and price of my pants are my variables. So we have 4 times the price of the shirts plus 3 pair of pants for however much pants cost is equal to $85.50. Then we go and spend buy 3 shirts for however much they cost plus 5 pair of pants for however much they cost for $115. So I want to solve that one, the next one. This one requires us multiplying top and bottom. I don't think there's one like that on the test. 433. And I don't want to confuse y'all. Let's just formulate that and call that the answer. What you would do is make 0 pairs. So let's do the next one. Let's find a solution to this next one, and that's how I'll show you elimination. But you won't have to multiply twice, so I don't want to set that up and confuse y'all. Here, the point is a solution. To see if it's a solution, you put it in there and check it. That's all well and good, but I want to show you how to solve it using this. What you would do to solve this using elimination is you would multiply one of these by either 6 or 2 to make 0 pairs. I'm going to go ahead and let's cancel out the y's because that gives us smaller numbers. So I have my 6x minus 2y equals negative 26. I multiply 3 times here. Negative 2x. I'm sorry. That needs to be negative. So that's positive, sorry. Now this is positive 2y equals positive 14. Sorry about that. 6 plus 2 is 8x. This goes away. Those are 0 pairs. They're gone. The whole point of this is get rid of a variable. We got rid of the y's there. And again, use your calculator. Negative 26, not minus, plus 14, negative 12. If we do that right, 6x positive 2. All right. Great. All right. Now divide by 8. Divide by 8. X equals. You are welcome to use alpha y equals on the calculator. We're going to get what is that? Negative 6 over 4, negative 3 over 2. Negative 3 over 2. X is equal to negative 3 over 2. I'm guessing that was not right unless I made a mistake, which could happen, of course. And we're going to take this and plug it in for x. All you have to do, negative, that's what's in here, and plug the negative 3 over 2 minus y equals negative 7. Make sure you have both negatives. One negative from there and one negative from my x value. So we get 3 over 2 positive because we have the 2. Minus my y is equal to negative 7. Subtract from both sides if you want. Oh, on the calculator. Negative y is equal to negative 8 and what? 1/3? No, 1/2. and then I change the sign right here. You should get 17 halves. You put it in the calculator. Y is equal to 8 1/2. So there should be your solution, unless I made a mistake. That's how you do it. Infinite number of solutions at the same line. I'm going to do a quick review of graphing a linear inequality. Tell you where the solution system is, where the solution to the system of inequalities is. You have to first make sure it's y is equal to, or standard form, y is greater than negative 4x minus 1 is what that turns into when you solve it for y. The only time you flip this inequality is if you divide by negative 1 in the process of solving for y. Let's go ahead and graph this one. Negative 1. Negative 4 is my slope, so that's negative 4 over 1. Down 4, 1, 2, 3, 4 over 1. Down 4 over 1. Up 4 over 1. Up 4 over 1. There's my skeleton. Now I need to figure out, do I use a solid line or a dashed line? Okay. If you have less than or equal to, greater than or equal to, or less than or equal to, you have a solid line. If you have greater than or less than only, it's a dashed line. This does not have the equal to part, so this is a dashed line. That means solutions are not on that line. Then which way do we shade? This is a greater than. If it is greater than, we shade on top. If you don't remember which way on top is, or can't figure it out because the line's too vertical, write your name on it. If you write your name on it, you'll always write your name on top of the line. This is greater than, we shade the direction of our name. Solutions for that one are over there. Then we have this one over here. It's already in slope-intercept form. 1 is my y-intercept, so I start there. My slope is 1 over 1. Up 1 over 1. There are a bunch of dots here. Now I'm going to go ahead and just put them all in here. Draw I'm sorry. It's a solid line because it has the equal thing on the bottom. There we go. And then that is a less than, so we shade below the line. This one's pretty obvious which way below the line is. Okay. My solutions are only in this double shaded area. The only place that should be questionable at this point are places on the line. Do these points up here on this solid line work? Yes, solid line works. If they are on the dashed line, that does not work. That works. This does not work. Those are all the basic skills that should be on this test. If you can, I would probably go over another elimination or substitution again. I'm sure it will be on the test as well.